Okay, so we're going to be talking about section 5.3. And what we're going over here is the rational zero theorem. Okay, so just to give you some background, if I wanted to solve, let's go x squared plus x minus 2 is equal to 0. And I wanted to solve for x. Okay, I could do that in a variety of ways, right? I could factor it, and that would be x plus 2, x minus 1 is equal to 0, and then my two answers would be -2 and 1, right? Those would be my answers. Or I could use the quadratic equation, okay, where a is equal to 1, b would equal 1, c is equal to -2, and then I'd plug it in. So -1 plus or minus the square root of 1 squared minus 4 times 1 times -2 divided by 2a, which is 2 times 1. Work it out, -1 plus or minus the square root of 1 plus 8 over 2. Keep going, -1 plus or minus radical 9 over 2. Keep going, which would equal -1 plus or minus 3 over 2, which would be -1 plus 3 divided by 2, and -1 minus 3 over 2. So that would be 2 over 2, and this would be -4 over 2, which would equal 1 and -2. Okay, so notice there's two different ways to do that. So you have ways to do a quadratic equation. Okay, so powers of 2. Now the rational zero theorem gives you things where it's bigger than 2. Okay, and to be honest, really what it is a guess and check method. Okay, so instead of just checking 1 and then -1 and 2 and -2 and 3 and -3, it gives you an idea of what it could be, even though, I mean, it'll decrease the odds of guessing it, or it'll increase the odds of guessing it a little bit. Okay, so the zero theorem is this. Okay, the possible values is plus or minus p over q. Okay, where q is the leading factors of the coefficient. Okay, so the leading factors of the coefficient, and the p is the leading factors and the p is equal to the factors of the constant value. Okay, and again, leading factors. Factors is the key word. So if I had a number, let's say q was 8, the factors of 8 would be 1, 2, 4, and 8. Okay, remember, two numbers that multiply up to that number is a factor. Factors of a constant, let's say 12. Okay, so 12, I would have 1, 2, 3, 4, 5, no, 6, yes, 7, no, 8, no, 9, no, 10, no, 11, no, and 12. Okay? So these would be the factors. And so if I had this, okay, this was 8, this was 12, to put it into the zero theorem, okay, plus or minus p over q, I would put plus or minus, these are all the p values, these are all the q values, so I put every single p value over every single q value. Okay, so my odds would be 1 over 1, or my numbers would be 1 over 1, 1 over 2, and again, it's plus or minus each of these, 1 over 4, 1 over 8, and again, plus or minus these, and then it's 2 over 1, and then 2 over 2. Now, some of them are repeat, like 2 over 2 is the same thing as 1 over 1. 2 over 4, 2 over 8. And then 3, and then 4, and then do it all with that. And these are all the numbers you would have to guess and check, okay, to see if it's an answer or not. Okay, so this is one of the longer ones. Okay, so let's go through an example and let's see how to do it. Okay, so the first one. The first one is h of x is equal to 3x to the fourth minus 7x cubed plus 5x squared minus 7x plus 2. And again, what we're trying to solve for is when can we solve for x to make this equal 0? That is what we're solving for. Okay, so the first thing we need to look for is the leading coefficient. Well, let's find the degree first. That's the highest power. So the leading coefficient is 3. The factors of the leading coefficient. The factors of 3 is just 1 and 3. That's nice. Okay, it's nice when they're prime. The constant value. The constant value is the number that doesn't have an x. It's 2. What's the factors of 2? That's just 1 and 2. Okay, so the possible rational zeros are going to be plus or minus. Now again, remember which one's P and which one's Q. This is P, is the constant values. This one is Q. Okay, P over Q. So it's plus or minus 1 over 1, which is 1, plus or minus 1 over 3, plus or minus 2 over 1, which is 2, and plus or minus 2 over 3. Okay, so I'm going to take that 1 over 1 and just make it 1. Okay, so I have 8 choices, plus 1, minus 1, plus 1/3, minus 1/3, plus 2, minus 2, plus 2/3, minus 2/3. And now what I'm going to do is just plug them in and see. Okay, so, and again, this isn't saying that each one is, it's just possible. Okay, I'm going to do it synthetic. Okay, so I'm going to go 3, -7, 5, -7, and 2. And again, if it's 0, if it is the correct solution, this number will be 0 at the bottom. So I'm going to plug in 1 first. So that's 3. Add. 3 times 1 is 3. -4, -4, 1, 1, -6, -6, and -4. Okay, so is this a solution? And the answer would be no. So 1 is no. Then I would check -1. Okay, so I do the next box. I'm going to do -1. And again, the same thing. 3, -7, 5, -7, 2. Okay, so I plug in 3. Or plus. That's -3. It's -10. It's +10. It's 15. It's -15. It's -22. +22, and this is 24. Okay, so if this is not 0, -1 is also no. Okay, well then I go to 2. And just keep going. Okay, I could do 1/3 next, and then -1/3, and then 2, and so on. Okay, so I'm going to try 2 next, because it's a whole number. So 2, what am I got? 3, -7, 5, -7, 2. Plug in. So 3, that'd be 6, plus. Oh, that'd be -1, -2, 3, 6. That'd be -1, -2, and 2 plus -2 is 0. Okay, so 2 is yes. So I got 1. And again, how many solutions do I have? I could have 4. Okay, so I'm going to have 4. I got 1 of them already. Now, since I've divided 1 out, I can use this instead of this now. Okay, so I can use 3, -1, 3, -1, and figure out the rest. Okay, so I still have -2, which I'm going to save you some time. That's no. Then I would go to 1/3, and I would try again 3, -1, 3, -1, and I'm going to try 1/3. Okay, so bring down the 3, plus. 3 times 1/3 is 1. 1 plus -1 is 0. 0 times that is 0. 3 plus 0 is 3, and 3 times 1/3 is 1. And 1 plus -1 is 0. Okay, so again, I got a 0. So 1/3 is yes. So I got 2 of them. Well, again, I need 4. Okay, but now I can use this. Okay, so this was x to the 4th up here. This was now x cubed, which this was x cubed. Now this is x squared. So I'm left with the polynomial 3x squared plus 0x plus 3. And I can set that equal to 0. Now, see how I'm down to x squared. This is where they'll get you. they want you to get it down to x squared and then use quadratic or use the other methods that we've already done. Okay, because at this point, usually they give you some imaginary answer where you couldn't just keep plugging these in. Okay, so I have two answers of 2 and 1/3. Now just solve this out. Okay, so I would minus my 3 over. So 3x squared is equal to -3. Divide off 3, so I get x squared is equal to -1. And then I square root. And remember, anytime I square root something to get rid of a square, I need to put plus or minus. Well, radical -1 is I, so x is equal to plus or minus I. Okay, so plus I is one answer, minus I is the second one. That's the third, this is the fourth. So my solution set for this is going to be plus or minus I, 1/3, and negative I and 2. So you're going to use guess and check method to get it down to the quadratic, and then you'll use your other methods to solve. Okay. All right. Let's go through 2 more just to see, make sure you get it. Okay. So x to the 4th minus 5x cubed plus 2x squared plus 20x minus 24. Okay, and that's v of x. So again, we're solving for zeros. 4 possible solutions. This is your highest degree. Leading coefficient, 1. Factors of that, 1. Your constant term, down here, -24. Your factors of that, and since it's going to be plus or minus at the end, we can just treat this as a positive. It would be 1, 2, 3, 4, 5, no, 6, yes. 3 times 8, 2 times 12, 1 times 24. Okay, so those are your possible. Now, again, this is P, this is Q. Okay, so these are the possible solutions. Now it's plus or minus 1 over 1. 2 over 1, 3 over 1, 4 over 1, 5. So it's just these. It's just plus or minus. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, and then the negative. So we have 16 choices to look at. And how do we check it? Well, I would use synthetic. Okay, so it'd be the coefficients 1, -5, 2, 20, -24, and you start with zeros. And you can start anywhere you want. Okay, I'm going to start with 1, bring down the first, and again, this has to be 0 at the end. So plus, 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 plus 1. 1 times 1 is 1, -4, -4. That'd be -2, that'd be -2. This would be 18, this would be 18, and this would be not 0. So 1 is a no. So then I would try -1, okay, and to save you some time, -1 is also no. So then I go to 2, and again, I got to find 2 this way. You have to find 2 to get it down to x squared. So I'm going to try 2. Again, 1, -5, 2, 20, -24. That'd be 1. Don't forget your plus signs. That'd be 2, -3, -6. This would be -4. This would be -8. This would be 12. This would be 24. And this would be 0. So I got 1. My first answer is 2. Okay. So instead of using the longer one, now I can use this. This is down to x cubed then. Since this was x to the 4th, I'm now down to x cubed. So now I'm going to use 1, -3, -4, and 12. And I'm going to try -2. That's 1. It's -2. This is -5. Forgot my plus signs. This would be 10. This would be 6. This would be -12. This would be 0. So anytime you get 0, that's an exciting thing because now we're down to another yes. So I have 2 solutions. And again, this was x cubed. this is down to x squared. So I'm left with x squared minus 5x plus 6 is equal to 0. I could keep going, okay? But sometimes at this point, they give you two imaginary, okay? So you could plug in every other one of these and you're not going to get 2 more. Okay, so at this point, I would stop and either use quadratic factor or just try to solve. Okay, and here I can factor. Two numbers that multiply up to 6 but add up to -5 is x minus 3, x minus 2 is equal to 0. So my answers are 3 and 2. Okay, and notice I have 2 twice. So 2 and 2 and -2 and 3. Okay, and that's okay because remember, at that point in the graph at 2, it just, I think it came this way, hit, and came back. So this counts as 2 answers. So my solution set is -2, 2, and 3. Okay, and you might note that this is twice. Okay. All right, one more. -3x plus x squared minus 3 plus x cubed is equal to 0. Again, you'll look for this and your constant term. Okay, so my leading coefficient is 1. My factors of that is 1. My constant is -3. My factors of that is just 1 and 3. Okay, so my possible answers are plus or minus 1 over 1 and plus or minus 3 over 1, which is 3. Okay, so I'm going to plug them in. And again, you need to write this in order. Don't put -3, 1, -3, 1. Okay, x cubed, x squared, x, and a number. So this should go 1, 1, -3, -3. Okay, and you got x cubed, so you just got to find 1. Okay, and I'm going to give you a hint. Okay, it's -1. So 1 times -1 is -1. It's a 0. 0 is -3. -3 times that is 3. 0. Okay, so this is yes. Now this was x cubed, and I only really need to find 1 because now I'm down to x squared. So it'd be 1x squared plus 0x minus 3 is equal to 0. Okay, see how there's no middle term? I can just solve. So minus 3, so I get x squared is equal to -3. Okay, and then I should square root it. Let's see, did I do something wrong here? 1, 1, -3, -3, 1, 1, -3, -3. Bring 1 down. I'm going to square root it. So I get x is equal to plus or minus radical -3. Now, you can't do that. You can pull out an I, though. Okay, so my answer is x is equal to plus or minus I times radical 3. So my solutions are -1 and then plus or minus I radical 3. All right, let me know if you have any questions.